SpaceX's mission to land on Mars isn't just a dream. It's a project that's being meticulously planned and actively pursued. But reaching Mars isn't just about building a rocket and taking off. It requires a highly detailed plan for navigation, entry, landing, and establishing a presence on an entirely different planet. Here's how SpaceX intends to make this monumental journey happen, and importantly, how they plan to actually land on Mars. Chapter 1. The Spacecraft, Starship and Super Heavy. SpaceX's Mars journey revolves around their revolutionary Starship spacecraft and the Super Heavy booster, an immense rocket stack designed for deep space travel. Starship is not only capable of carrying massive payloads, but can also hold up to 100 passengers, which will be essential for colonization efforts. This system is fully reusable, meaning it can launch, land, and launch again, significantly lowering the cost of space travel. The Super Heavy booster, towering at around 70 meters tall, will provide the necessary power to break through Earth's atmosphere. Once Starship and Super Heavy reach low Earth orbit, they separate, with the booster returning to Earth for reuse. Starship will then continue the journey to Mars, covering around 140 million miles. Chapter 2. The journey to Mars. Once in space, the path to Mars relies on perfect timing. SpaceX has to wait for a launch window, which happens about every 26 months when Mars and Earth align favorably. During this window, Starship can efficiently navigate through interplanetary space using its Raptor engines for initial acceleration and mid-course adjustments. After that, it will coast through space, relying on minimal adjustments and saving fuel for when it reaches Mars. This journey will take approximately 6 to 9 months, depending on the trajectory and the positions of Earth and Mars. Throughout this journey, astronauts will face a range of challenges: radiation exposure, isolation, and the physical impacts of prolonged weightlessness, all of which SpaceX and NASA are working to mitigate. Chapter 3. Preparing for Mars entry. As Starship approaches Mars, it must prepare for entry into the Martian atmosphere. This phase is among the most challenging aspects of the mission, as Mars has a thin atmosphere compared to Earth, making it difficult to slow down the spacecraft. This is where SpaceX's heat shields come into play. The Starship's thermal protection system is designed to withstand intense heat from atmospheric entry, using a unique, highly durable material that can endure extreme temperatures. During this entry, Starship will initially fly in a belly-first position to increase drag, reducing speed significantly as it approaches the Martian surface. This technique, called aerobraking, uses the atmosphere to dissipate energy and slow the spacecraft down. Chapter 4. The Landing Maneuver, the Belly Flop. After aerobraking, Starship will execute one of the riskiest parts of the mission, the belly flop maneuver. To land on Mars, Starship will tilt and descend belly first, keeping it horizontal and using atmospheric drag to further slow down. Once it reaches a certain altitude, it will then pivot to a vertical position and ignite its Raptor engines to make a controlled descent. This landing technique is essential on Mars due to its thin atmosphere, which doesn't provide the same cushioning effect as Earth's. In the final moments before touchdown, Starship's engines will adjust for a precise landing. It's an incredibly tricky maneuver that SpaceX has tested with multiple prototypes on Earth. The goal is for Starship to touch down gently on Mars, fully intact and ready for future missions or colonization efforts. Chapter 5. Landing Site and Preparations. Selecting the right landing site on Mars is critical. SpaceX has identified several potential areas, with a focus on locations that offer resources like water ice, which can be converted into oxygen and hydrogen fuel. Most of these sites are in relatively flat regions near the Martian equator, where temperatures are more moderate and sunlight is available for solar energy. Upon landing, Starship will deploy a set of solar panels and begin powering its systems. These panels will generate electricity to keep the spacecraft functional and sustain any crew members on board. The initial missions will likely carry only cargo or robots to establish infrastructure and prepare for human landings. These early missions may include autonomous systems that set up habitats, rovers that scout the area, and possibly even equipment to extract resources from the Martian soil. Chapter 6. Human Landing and Mars Base Preparations. Once the landing maneuvers are perfected and the area is adequately prepared, SpaceX plans to send astronauts to Mars. The journey and landing will be identical, but this time Starship will carry not only a crew but also essential supplies. This will include life support systems, food, medical supplies, and equipment to build a base on the Martian surface. The astronauts' first tasks will be to secure the landing site, check all systems, and begin assembling the base. The base will initially consist of inflatable habitats, greenhouses, and a small power station to ensure survival. Over time, the goal is to make this base self-sustaining, using Martian resources like water ice to produce oxygen and fuel. Chapter 7. Fueling for the Return Journey. One of the unique aspects of SpaceX's Mars mission is that Starship is designed to be reusable. After dropping off cargo or crew, it can return to Earth, assuming it's refueled. SpaceX's plan involves using the Sabatier reaction, a process that combines hydrogen, likely extracted from water ice on Mars, with CO2 from the atmosphere to produce methane, which the Raptor engines can burn as fuel. This in-situ resource utilization means that Starship can be refueled on Mars, eliminating the need to bring return fuel from Earth, which would be extremely costly. The creation of a methane-fueled economy on Mars is a cornerstone of SpaceX's vision for Mars colonization. Chapter 8. Challenges and the Future. Landing on Mars is a massive challenge, but establishing a long-term presence is even more complex. Mars is cold, has intense radiation exposure, and dust storms that can last for weeks. To counteract these conditions, SpaceX will need advanced technologies for habitats, radiation shielding, and robust energy sources. In time, the infrastructure might include underground shelters, nuclear reactors, and even fusion reactors to support large-scale human life. SpaceX's Mars mission represents the first true step toward making humans a multiplanetary species. The journey is daunting, filled with risks, and will take years to accomplish fully. However, with each step forward, each successful launch, each precision landing, SpaceX is bringing humanity closer to becoming a species that lives beyond Earth. Elon Musk's vision to land humans on Mars and create a thriving colony is no longer confined to science fiction. With innovative engineering and relentless determination, SpaceX is well on its way to making Mars an attainable destination. The challenges are immense, but the technology and the willpower to overcome them are advancing every day.